All right, students, we'll do some problems from this assignment. First, we should recognize this is all about Pythagorean theorem. Everybody already knows this. We've done it multiple times. We know Pythagorean theorem is a squared plus b squared equals c squared, with c being the hypotenuse, which means, again, it can only be in right triangles. So that's why you'll see everything here is right triangle. A and B are called, should have already said it by now, the legs. It doesn't matter which one you call, which one you call A and which one you call B. Now recall, the side opposite the angle was created by that angle. So that's why this side is called little a, because it's opposite of big A. So side lengths are labeled by lowercase letters. Remember, angles or points are always with capital letters. And so little a was formed by big A. Little b was formed by big B, and little c is formed by big C. Okay, and we talked about already about in the last test about being able to put them in order from smallest to greatest. Okay, and doing that. All right, so here you're just checking to see which one of these is true or false. How can I manipulate this Pythagorean theorem in different ways to see if it's false or true? Okay. This next section here says find the unknown side length, obviously the x. Simplify answers that are radicals. So this means, and the word for saying that, you've heard me say it all along, exact answer. That means you don't put in the calculator and give me a decimal. No decimals allowed. It's always exact answer on all homework and DCAS unless they tell you to round to a specific decimal, like the 10th or the 100th spot. Then it says tell whether the lengths form a Pythagorean triple. Well, you should already know what a Pythagorean triple is that all the side lengths are natural numbers. No radicals involved. So 7 automatically, just looking at it, cannot be a Pythagorean triple. It's got a radical in it. Okay? They'd have to work out all three sides to be natural numbers. No radicals. Okay. I will be able to tell you right now that there are 2 Pythagorean triples on here. So if you know your Pythagorean triples, you'd be able to put down the answer right away. Let's go ahead and look at 11. That's probably the one that's going to be the most trouble for most of you. Notice I have what kind of triangle is this right here called? Besides it being a right triangle, we know that. There's a more specific name that we can call that right triangle. We've used this word before. It's given away by these 2 hash marks. What does it mean when you have 2 side lengths the same? At least 2 side lengths the same. That's an isosceles right triangle is its most specific name. It's isosceles because it's got at least 2 congruent sides, and it's a right triangle because it has the right angle symbol there. Okay, so that means both of these have to be 45 degrees. So it's a 45, 45, 90 special right triangle. Special right triangles will be coming up next class. Okay, so now you're seeing example 1. That's one type of special right triangle. I'm not going to show you the shortcut on doing that. That'll be the next lesson. If you watch the video ahead of time, you'll be able to see how to do that without doing Pythagorean theorem because it's a special right triangle. But in this case, since we're not doing that yet, I'm not going to show it to you unless you want to go ahead and look at the video ahead of time for next class, and you'll be able to do that. So we know a squared plus b squared equals c squared. Okay, x squared plus x squared, you should know from algebra 1 is 2x squared. And when I square a number, I distribute that squared through both of them. So it says 8 squared is 64, and square root of 2 times square root of 2 is 2. 64 times 2 is 128. I divide both sides by 2, and I get x squared equals 64. I take the square root of both sides, and I get x equals plus or minus 8. But of course, we cannot have a negative side length, so it wipes out the negative sign. I'm trying to change the color here. Wipes out the negative 1, so it's only positive 8. So 8 is my answer. X equals 8. Okay. Like I said, if you know your special right triangles, you learn it, you'll be able to just write down the answer looking at it. Okay. Here it says, given the side lengths of a right triangle are here. All three side lengths of the triangle are integers. So they form a Pythagorean triple. Now they call them integers, but obviously it can't be a negative number. You could get more specific down to natural numbers. Some might want to say whole numbers, but whole numbers include 0. And of course, you can't have a side length of 0. So it must start at 1 minimally. And the 1, 2, 3, 4, etc. are called natural numbers. We've gone over this in class before in our number system. So this could either be A and B, or it could be B and C. Okay, one of the two. A and C be the same thing as B and C, because it doesn't matter which one you call A and B. So either I'm squaring these two, add them together, and it's going to come out to be C squared, or I would have B squared plus A squared equals C squared. And if I'm calling this B here and the other one's C, if I'm calling 40B, remember the longest side is always C. If you have a C involved here, so 41 would have to be the C in this case if you're calling it between B and C, and then you'd solve for A. Okay, using your theorems above. Or you'd say both of these are A and B and see if C works. Only one of these combinations works. You have to go ahead. I'm just setting it up for you, but it's got to be one of these two situations for all 14 or 15. And remember, your answer has to count to be a natural number. So if you'd plug it in, and this comes out, and if you call this A and B, and then I square them, sum them together, take the square root, and it comes out to be a natural number, then C is that natural number that you just found. But if that doesn't work, then this has to be the case. The second one would have to be the case. And so C is 41, A or B, doesn't matter, whatever you call it, is 40, and you'd solve for the other leg. Okay, next page. Decide whether numbers can represent the side lengths of a triangle. If they can, classify as right, acute, or obtuse. Okay, we're reviewing this. We've already done this. Okay, remember, in order to be a triangle, the two smallest have to be larger. The sum of the two smallest, 5 plus 12, have to be greater than the longest, 13. In this case, for number 1. Doing number 1 over here. Okay, first off, you should recognize 5, 12, 13 is a Pythagorean triple. And so that's true. 17 is greater than 13. So yes, it can form a triangle. And since you should recognize 5, 12, 13 is a Pythagorean triple, then you know it's a right triangle right away. Okay, otherwise, remember, to see if it's acute or obtuse, you're checking to see how C squared compares with the sum of A squared plus B squared. If C squared is greater, then the answer is obtuse. If C squared is less than A squared plus B squared, then the answer is acute. So this is all review. You got tests on this in your last test. Okay, but several people missed this. I want to make sure you review it. Okay. Here, you are doing the same idea, except for instead of giving the side lengths as you are here, you're just giving points. And then you have to calculate the side lengths using either Pythagorean theorem or distance formula, as we've already done. So that's, and then using the same thing above as we just did right there. Okay, and so that ends the information you need for this homework assignment.